So hello everyone. Today we are going to solve this problem garden squares. In this problem, chef has a rectangular garden which can be represented by n rows and m columns. And in this garden, in each cell, chef planted a grass of some color. And the elegance of garden is defined by the number of squares in which each corner is having the same color. And we have to count the number of such squares or the elegance of this garden. So we are given chef's garden which is having n rows. So let us suppose this is first row, then second, then third till n rows, and m columns, first column, then second, then third, and till m columns. This is first row, then second, then third, and so on till n. And in this garden, in each cell, he has planted a grass of some color. Let us suppose this grass is having a color, and the color of the grass is defined by an alphabet. Let us suppose in this cell grass is of color A, in this cell it's of color B, and it's in this cell it is of color G, and then so on. And we also have to take care of the case that these colors are case sensitive. These colors are case sensitive, that is capital A is not equal to small a. So this A and this A are different, are considered different colors. So each cell can have different colors, or which is defined by an alphabet. Now we have to find the number of such squares. Let us suppose this is a square in which all the four corners, this one, this one, this one, and this one, all four corners are having the same color. That means same alphabet. If this square is having alphabet A in all the four corners, then we can take this square. So we have to count all the squares in which each corner is having the same value or same alphabet or same color. So let's look at the first test case. In the given test case, we are given n equal to 4 and m equal to 4. And we are given this matrix, that means n rows and m columns, 4 rows and 4 columns, 1, 2, 3 and 4, 1, 2, 3 and 4. We are also given the alphabets, that is the color of each cell, which are as A and A, then B and B, then again B and B, and then this. Now we have to calculate the elegance of this garden, or all the squares in which all the four corners are same. So let us consider each square. We are also given the condition that the square should at least have 4 cells. That is, a square, we cannot consider this square of 1 cell. We have to consider at least a square of which contains 4 cells. So we can consider this square, we can also consider this square, and we can also consider this whole garden as a square. So now we have to calculate the elegance of the garden and the number of these squares. So let us take this square as our first square. Now we can see that all the four corners are having the same color. So we can consider it as our answer. So our answer will be incremented to 1. Now let us consider this square. In this square, all the four corners, this corner is having the value A, and this is having a value A, and this is having a value B, and this is having a value B. So all four corners are not having the same value, hence we cannot consider this square. Let's move on to the third square. Let's consider this as our third square. In this square, we can see that all the four corners are having the same value, so we can increment our answer. So now our answer will be 2. Similarly, we can take this square and check if this meets our condition. No, it doesn't, because all four corners are not same, and then so on. We can check each and every square and check the condition that all four corners should be same. So it's pretty much straightforward approach. We have to check for each and every square. So let's discuss the approach for this problem. Since the constraint for n and m are not that high, so we can traverse each cell, and for each cell we can consider that cell as the top left corner for all the squares containing it. So this, for this cell we can consider this square, and then also this square, and then finally this square. Then we will move on to next element, this one. We will consider this square, then we will consider this square of side 3, and we cannot move further because we cannot form a square of size 4 here, so we will stop here. Then we will move on to next element, which is this. Then we will consider all the square which are having this element as their top left corner. So we will consider this square. We will consider only this square because we cannot form a square with the side 3. Then we will move on to the last element. For this element we cannot consider any square, as square of size 1 is not allowed, and square of size 2 we cannot form because we don't have sufficient element after this. Similarly, we will traverse each element and check for all the squares which are having these elements as their top left corner, and check for the case that all the four corners are having same value or not. If this is the case, we will increment our answer, otherwise we will not. And at last we have to print our answer. I hope this approach is clear to you, and let's move on to the C++ coding part. For each test case, we are taking input n and m, which represent the number of rows and columns of this chef garden, and then we have created a matrix of size n into m, and then we have taken the input for this matrix, which represent the color of each cell. We have initialized our answer with 0, and then we are traversing each and every cell. These two loops represent the traversal of each and every cell, and for each element we are considering every square which is having these elements as their top left corner. Then we are checking the case if all the four corners are having the same value. If this is the case, we are incrementing our answer, and at last we are printing our answer. I hope this solution is clear to you, and thank you.